Okay, this is our end of course final exam review day 2. We're starting at number 24. This one has all the fraction stuff that we did in the second semester. So simplify means to factor and cancel. If you notice the first one, it's a difference in squares. So that means you should be able to square root each term. Don't put the negative inside the square root because that's not how we do it. So that should give us a z and a 7, which means that the other one is also going to be z and 7. And then one's going to be a plus, the other is going to be a minus. And then down at the bottom, we have z plus 7. Now the question asks for restrictions, and restrictions come from setting the bottom equal to 0. So if I take x plus 7 equals 0 and solve that, x equals negative 7 is the restriction. So just by looking at the choices, that doesn't really help us because all the choices have negative 7. Then the rule is if it's the same on the top and the bottom, and that goes for the entire parentheses, you can cancel it. So our final answer is just z minus 7, and that's our restriction over here. So the correct answer for number 24 should be choice B. Number 24 says multiply and state any restrictions on the variable. So this one is the same type of question. It's just that now we have 4 parts that we got to kind of consider. So for the first one, if I have x squared minus 2x minus 24, you can do that one in the solver. So if I go into my solver, degree 2, we'll put in 1, negative 2, so not 2 negatives, and negative 24. And then we hit enter. Now we don't want the solution, so these are solutions that we're looking at on the calculator, so we've got to switch the signs. So this would be x minus 6, and the other one would be x plus 4. Okay, the next one is on the bottom. It's x squared plus 7x plus 12. So that one we're going to do the same thing. We're going to put 1, we're going to put 7 and 12. So those are going to be x plus 3 and x plus 4 because they're always opposite. Next one is the difference of squares. That one we don't really need the calculator because we get to square root each one. So that should be x plus 1 and x minus 1. And then we have a lonely x minus 6, and that one cannot be factored at all. Now, I'm dividing this up into the top and the bottom. The reason why I'm doing this is because in the bottom, we're going to get our restrictions. So our restrictions are going to be the opposites of what are in the parentheses. So we have 1 at negative 3, 1 at negative 4, and 1 at positive 6. Now, if you look at the choices, it doesn't really help us much because every restriction is the same on A, B, and C. Now is the simplified part. If it matches on the top and on the bottom, you can cross it out. So x minus 6 and x minus 6. We have x plus 4 and x plus 4. So our final answer is going to be whatever's left. So x plus 1, x minus 1 on top, and then x plus 3 down at the bottom. So it looks like correct choice for number 25 should be choice C. Number 26 is the same, except now it's a division problem. We know that when there's a division problem, you're supposed to flip it over. So I'm going to go ahead and do that first. I'll do these 4 problems like this. So the first one is 4x squared minus 2x. You're going to take out the GCF here. It looks like it's going to be 2 and x. So I'll have a 2x in the front, and then I'll have 2x minus 1 in here. The one at the bottom is going to go x squared plus 5x plus 4. That can go into the calculator, into our solver. So I'll hit exit. It's 1, 5, and 4. So the solver says minus 1 and minus 4, so we're going to put plus 1 and plus 4. Now here's where you need to be careful. These two need to switch places. So I'm going to put 2x down here at the bottom, since that one can't really be factored anyways. And then the other one is x squared plus 2x plus 1. And that again is the solver. So I can try to find two numbers that multiply to 1 and add to 2. The solver thing is going to tell us it's the same answer twice. So we're going to have two parentheses, both with plus 1. So x plus 1 and x plus 1. Now your restrictions, again, they come from the bottom. So the first parentheses gives us a -1. The second parentheses gives us a -4. And since the third one in blue doesn't have parentheses, it's automatically a 0. So just from there, we can get rid of choice B. So now what we're going to do is we're going to try to cancel if we can. We're going to cancel all the matching stuff. Parentheses with parentheses, non-parentheses with non-parentheses. So I see a 2x and a 2x. I see an x plus 1 and an x plus 1. So it looks like we're left with a 2x minus 1 and x plus 4. 2x minus 1. Oh, I almost lost one. Sorry, we left this one off. So x plus 1. That should be our final answer. So this is number 26. The answer to number 26 looks like it's going to be B. Number 27 says subtract and state any restrictions on the domain. Now when we subtract, we have to make sure that the bottoms match. If the bottoms don't match, we have to change them so that they do match. So this question right here, if you look at the first bottom, there's a GCF. If I pull out the GCF, you'll see that that y plus 2 matches this y plus 2. So since our second fraction is missing the 2, I'm going to multiply this one by 2. So basically what we're doing is we're making it so that the bottoms are going to match. And once those bottoms match, now we can just combine the tops. So I'll have y minus 6. And it says state the restrictions. The restrictions, they come from the bottom. So my restriction is going to be just -2. And then that's the answer. So y minus 6 with a restriction of -2. So these are not them because of the restrictions. So what am I looking at? Choice B. 27 is choice B. Number 28 says find the solution. So now when we're talking about the solution, it's kind of done the same way. You have to give it what it doesn't have. So if I'm going to make a denominator that's going to represent every denominator here, that denominator would be x and x plus 2. So this one is missing the x plus 2. And then this one right here is missing the x. The third one is missing both. So we're going to have to multiply this with x and x plus 2. Once we do that, we don't need the fractions anymore. So we'll have 15x plus 30 plus 9x squared minus 7x equals 9x squared plus 18x. Now this question is kind of messy, so I'm going to start to organize it by combining like terms. So I'll leave the 9x squared in the front. What is that? 15 take away 7 is positive 8. So I'm going to put positive 8x and then 30. Then I'll have my 9x squared plus 18x. And then I'm going to subtract 9x squared, and this actually works out nice because now we don't have to worry about those guys anymore. So now I'm just going to get all of the x's to one side. So I'll subtract 8x. Might as well put it over here since 18x is all alone. So that's 10x is equal to 30. Divide by 10. And x equals 3. And again, if you want to work backwards, you can always go back and plug these in. You can plug a 3, plug a 3, and plug a 3, and see if it gives you 9. Number 29 says convert the equation into a logarithmic form. So remember how this works. We've got 5x plus 3 equals 125. I made a dumb joke that it's all about that base. 5 is the base here, so this is going to be a log base 5. And then the remaining stuff just flip-flops. So this is going to be x plus, flip-flop it. This is going to be 125 here, and then the x plus 3 goes to the other side. Doesn't say to solve it, it just says convert. So we're looking for log base 5, 125 equals x plus 3. That gives me choice A. Number 30 says now actually solve it. So when we solve something, that has exponents, first thing you want to try to see is, can we make them match? So my strategy for this, if you were with me in class, I said, take the big one and turn it into the small one. So if I turn 27 into a 9, 9 squared is already 81, so that's not going to work. I need to make it into a 27. So what that means is we need to change the old one for the small one. The small one would be 3 to the second power, and there's already an x there, so I'll just put it in parentheses. 27 would be 3 to the third power, and then I'll put the x minus 1 in parentheses. So if it has stuff already in the parentheses, or already up there, you can just put it in parentheses. Now the reason why we do this is because once the bases match, you can get rid of them. So now we're just solving this, and I'll just go ahead and simplify that there. I'll distribute it. So 3x minus 3. I'll subtract 3x to get x to one side. And then I'll just divide by -1, so x is completely alone. So I end up with x equals 3. So for number 30, choice C is the correct answer. Number 31 says, solve for x. So this one is a log problem. The main idea on a log is you want to try to get the log by itself. So I'm going to do log base 3, x minus 6, plus 4 equals 11. First thing I'm going to do is get rid of the 4. I'm no longer hand row to 5. And that's going to give me a 7 right here. And I have log base 3, x minus 6. Now that x is inside of the log, and I can't touch it. So what I have to do is I have to convert it. Once we get to a point where we get stuck, we take it out of the log format. So again, it's all about the base. The base is a 3, so I'm going to make a big 3 here. And then I'm just going to flip-flop these guys. So if I put the 7 over here and x minus 6 right there, I can go into my calculator and I can type in 3 to the 7th power. Let me go into my menu. I'll go into the calculator and do 3 to the 7th power. It's going to be a pretty big number. 2,187. And then add 6. So 2,193. So correct answer for number 31 is choice A. Number 32, which function matches the graph? So first, you have to be able to tell the difference between exponential growth, exponential decay, and logs. So I'll show you exponential growth. That would be something like 2 to the x power. That graph should look like this. If I have exponential decay, a decay would be like a 1/2 to the x power. That one would go like this. If I have a log graph is actually going to go like this. So you kind of have to memorize this. Now, how do I know that this one is a log? Because of the word log. Logs create vertical asymptotes. So the way my mind works is this L right here looks like the dotted line for the asymptote. So that means it can't be these two. If the asymptote was going across, then it can't be a log, because we don't write log like this. It goes like this, log. So that way when asymptote goes this way. Okay, here are these. So now we just got to figure out how the asymptote impacts the equation. This asymptote looks like it's at -4. So what that means is your log, inside of your log, has to be the opposite. So that means that the correct answer has to be choice A. Your asymptote comes from inside the log. So if x equals -4, that means inside the log has an x plus 4. Number 33, it says solve for x. So we have to use our condensing rules. We don't want to see the log so many times. There's 2 different logs here, but there's a minus sign, so that tells me I can write it as 1 log with fraction. So the first one is x plus 1, and the second one is x. The other side is 3. Now at this point, we're kind of stuck, because it's got the x inside of the log. So again, it's all about the base. So I'm going to take a big base, and I'm going to flip-flop all of this stuff. So 2 to the third is equal to x plus 1 over x. And then what I'm going to do is I'm going to write 2 to the third is 8. And this is now just a proportion. That means we can turn it into a fraction and cross multiply. So that's 8x. 1 times x plus 1 is just x plus 1. So I'll subtract x from both sides. So I have 7x equals 1. divide by 7, so x equals 1/7. Then what we want to do, just to be safe, we want to see is if we put a 1/7 here and a 1/7 here, is it going to make 0? The answer is no. If it made 0, then we would say there isn't an answer. It's extraneous, basically. So number 33 is choice A. Now this thing jumps over to number 42, but that's okay. It says, what is the 15th term of this pattern? So this pattern goes from 17 to 15 to 13, and so on. So we have to know what type of pattern we're dealing with. So to get from here to here, it looks like we're doing a -2. So to get from here to here, it looks like we're doing a -2. So because that's a -2 both times, that means we're dealing with an arithmetic pattern. If I want to find the 15th number of the arithmetic pattern, it looks like this. AN equals A1 plus B, n minus 1. So this 2, -2 is the B. This is A1, and n, that's this guy. N is 15. So if I plug all of this into this formula, it's going to be 15. A1 is 17. D is -2. And then we've got 15 take away 1. We type that all into your calculator. The answer to number 42 ends up being -11. Number 43, it says, what is the explicit formula for the following sequence? So let me write this one down. It goes from 2 to -6, back to +18, and then that pattern continues. So the pattern looks like, if I was going to do addition and subtraction, this would be a -4, but then this would be a plus not 4. Okay, so that's not good. It needs to be the same number. So that means that we're going to try division. So if I multiply, this would be times -3. And if I multiply again, that's times -3. So that means that this is a geo sequence. So geo. And it says, what is the explicit formula? So the geometric formula goes like this. AN is equal to A1 times R to the n minus 1. So this one right here is your R. This is A1. So this formula is going to be AN is equal to 2 times -3 to the n minus 1. So it looks like the correct choice should be, what am I doing for 43? That should be choice B. Number 44 says, write a recursive formula for this pattern. First thing is always determine what kind of pattern you have. So from here to here, it looks like +3, +3, +3, +3, +3. So I just want to check it all the way through the pattern just to make sure. It's a +3 every single time. So that means it's arithmetic. Almost spelled that wrong. Okay, so if I'm going to write a pattern for this, I need to define where to start. That's going to be A1. So A1 has to equal 3. So just from that, we can get rid of this choice and this choice. Now we have to say the next number is found by taking the previous number, n minus 1 is the previous number, and then attaching the +3. So that's going to be choice A. Number 46 says, what is the value of sine of 5 pi? Well, the thing about this is this circle, it only goes to 2 pi. This is 1 pi. So what I need to do is I need to subtract 2 pi. If I subtract 2 pi, that's going to be 3 pi. Still too big. If I subtract 2 pi again, so that's 1 pi. So if I want to find the sign is the second number in the parentheses at 1 pi. So that would be 0. Number 40, oh, this doesn't even have a number. It says select the expression that does not have the same value. So what I want to figure out is what is the cosine of pi fourths? Here is pi fourths. Cosine is the first number. So that would be radical 2 over 2. So I'm going to write that down over here. Radical 2 over 2. Now I need to go through and check all these. So the sign at pi fourths, sign is going to be the second number. So the sign at pi fourths is the same. That's not the one I want. I want the one that is not the same. Then I'll go to the cosine of 3 pi fourths. So here's 3 pi fourths. Cosine is first number. So that'll be this one. Those are not the same. So choice B should be the correct answer. Number 48 says, what transformation from the parent function f of x equals sine of x to the function sine of x minus pi is plus pi? So they're just saying list the transformations. So the first thing is, which way is this moving? Well, if it's with the x, it's going to be opposite because your x lies. And so if that's a minus pi would be left, but they're lying to us. So I'm going to add pi. So I'm actually going to go to the right. Pi. And then this is the last number is your k. That's your vertical shift. So that's going to be up 5. So up 5 and right pi. Choice C. Number 50, it says, what is the equation of the graph below? So the first thing we have to figure out is where is the midpoint or the midline. So I'm going to go the highest, and here's the lowest. So that means that my midline has to be here. Now the reason why that's important is because I need to go see where it starts at. Since it starts on the top, that means it's a cosine. Now the thing about this problem is that all the choices say cosine, so that doesn't really help us. Next thing we're going to figure out is the amplitude. Your amplitude is the distance from the middle up to the top. That's 2, and you can go to the bottom also, because it's also 2. So that means that D is not the correct choice. Last thing we're going to have to do is figure out the period. Now the nice thing about a cosine is the end of the period of the cosine is going to be the next maximum. So that point right there. So what we need to figure out is what is the value of the x-axis there. So if that second line is 2 pi, that means this is 1 pi. So this would be 3 pi, and this would be 4 pi. Now, if my period is equal to 4 pi, and the period formula is 2 pi over b, I can put this over 1 and cross multiply it. So I would have 4 pi with a b on it is equal to 2 pi, and then I would divide by 4 pi. All of this crosses out, pi's cross out, and if you simplify 2 over 4, it's 1/2. B goes in front of x. So the only one it could possibly be is choice C, because it's 1/2 x or x over 2. Last one says, what is the solution to the system of equations? So if we look at a system of equations, it's going to be anywhere where the graph touches each other. Not the axis, but the curve and the line. So there's one solution here. Looks like it's at pi 6 and 2. I don't see that listed. There's another solution right here. It's at 2 pi thirds and 0. 2 pi thirds and 0. I don't see that one either. And then here's a third answer at 7 pi 6 and -2. So it looks like that's the only solution of this graph. So I believe that's it for day 2. So hopefully that helped. And now all that's left is we're going to review like crazy until the day of the final exam.